you've been enjoying the Engineering Expo, many of you. So we're happy to have you here today. So on behalf of FIU, we will say it again, welcome to the College of Engineering at Florida International University. As you know, the main campus is a few blocks to the south, and this is just the engineering campus. But located here on the engineering campus is the Wall of Wind. How many here have seen the Wall of Wind today? Any of you? Not yet? Okay. Well, after 1 o'clock, if you have the time and want to see the Wall of Wind, you're more than welcome. If we run out of time and we want to see the Wall of Wind before the competition, we can make arrangements for that as well with me. So, my name is Eric. I'm Eric Salna, and I'm an Associate Director with the International Hurricane Research Center. And we work and collaborate and partner with the College of Engineering, and specifically Civil Engineering, with the Wall of Wind Research Facility. So I am helping facilitate the Wall of Wind Challenge, and we have many people involved. So as we move forward in the next couple of months, I'll be the main point of contact with emails and information. We'll be providing lots of information starting next week. We have a Wall of Wind web page that I will start updating with information as well. We will start a frequently asked questions page, FAQs. As questions come in from all the teams, we will then share all the questions and answers with everyone, to be fair. So as everyone asks questions, we want to make sure everyone gets as much information as possible about the challenge. We're so excited to have you all participate in the challenge. Right now we have at least 8 high schools involved. We may end up with 10 to 12 high schools when it's all said and done. We're still in communication with some additional high schools. So there'll be a good competition, a good field of teams. We have done this Wall of Wind Challenge now for several years. Each year the challenge is different as far as what we give to you as the teams. And you have to come up with the solution. And what really makes the Wall of Wind exciting is that you get to bring your project here to FIU on the day of the competition and actually test it in the real Wall of Wind. And that's part of the scoring. As you will see when we do the competition, there's going to be 3 components. There's going to be a technical paper is one component. The second component is oral presentation. And the third component is the actual physical test of your project. Of the 3, it's weighted. Of 100%, the physical test is going to be 50% of your score. The oral paper and the technical paper each will be 25% of your score. So the highest weighted part of your score is going to be your testing with the Wall of Wind. On your team, you can have as many students participate on your team. You can have 5, 15, 20, 30 participate, which means you can divide up what needs to be done. That's okay. However, the day of the competition, only 4 students actually are allowed to represent your team on the live competition on May 20th. Everyone else who helped, all the other students, teachers, faculty, principal, parents, they're all welcome to come on that day and observe the activities. They're all welcome to be spectators and come cheer all of you on that day. Only 1 team is allowed per school. Some schools have already asked, can we have more than 1 team? Just 1 team is submitted to represent your school. The technical paper will be due before the live May 20th competition. I'll get the exact date, but May 20th is a Wednesday. I think the technical papers will be due by Monday at noon. And we're going to be grading those papers. So we'll have all those papers graded by Wednesday. Because on Wednesday, what's live is your actual physical test and your oral presentation. In your oral presentation, there'll be live judges, and for the physical test, there'll be live judges. So on that day, you'll be going to 2 different places, and we'll have a big schedule of which school goes where. Everyone's going to arrive by 9 o'clock at the latest or so. We'll get everyone out of here at 1:15. We're going to get all the testing in, all the oral presentations in, as well as the scoring, and all the awards will be presented before you leave for the day. So we will know who is going to be the champion of this year's Wall of Wind Challenge. So between now and then, as I said, I'll be providing information. We actually will be providing you with some money to buy materials and supplies. We pay for all the bus transportation. We will provide you lunch. We provide you just about everything. So there's very little out-of-pocket expense from all of you. We have a grant from the Florida Division of Emergency Management that is funding the majority of this competition. So that's how we get to make everything happen. We have judges that are VIP judges. We have some of the biggest experts in wind engineering as judges for the physical test. For the oral tests, we have Max Mayfield, the former director of the National Hurricane Center. We will have a meteorologist from CNN. We will have a meteorologist from the Weather Channel. They are going to provide live coverage. We usually have media come on that day. So we will then send the forms ahead of time, those as far as videotaping students, and to get the okay from your end as far as if any one of you are videotaped on television. We just need those approvals ahead of time, but you'll get that before the day of the competition. It's an exciting day. Miami-Dade County schools, they love the competition. There's lots of, bridge building competitions, science fairs, solar car competitions, but the Wall of Wind Challenge is a one-of-a-kind challenge. And we love it because it's not only all about engineering, it's STEM education. And it teaches us, as you learn about the Wall of Wind, how we can build better and build stronger. Because the Wall of Wind, the purpose of it, we built it so we can test structures. And how can we make our school buildings, our homes, our businesses, how can we make these structures safer to ride out a hurricane situation in wind? Because which state in the United States gets the most hurricanes? Florida. We live in the hurricane capital of the United States, and South Florida is ground zero. So that's why we have the Wall of Wind, the most powerful research university facility in the entire world. And you all are going to be able to firsthand have a real experience working with the real Wall of Wind. Not everybody gets that opportunity. And to be able to come in and use this facility is a great opportunity. On the website, you'll see videos from prior competitions and media coverage, lots of information, technical papers to learn about the content. So what we're going to do now is we're going to show you a PowerPoint. This PowerPoint is going to talk about this year's new challenge. But to do the challenge, you're going to need to understand some of the engineering concepts involved. Each year, the challenge, there's engineering concepts that stay the same, but then there's some new engineering concepts related specifically to the challenge. That's what you're going to hear today. So we're going to talk about that as well as the rules and guidelines for the challenge. So right now, I'm going to be now having the director of the Wind Engineering Research Facility. He is here with Civil Engineering. This is Dr. Arindam Chowdhury, and he is going to now present the topics related to this challenge. So let's give him a big hand.
Welcome everybody to the Wall of Wind Challenge 2015. So as Eric mentioned, we are going to go through some basics. So wind engineering is basically a part of the civil engineering, and we always deal with wind structure interaction, and we are going to show you a few things about wind engineering. Now wind engineering is a multidisciplinary topic. So it has fluid mechanics, meteorology, structural mechanics, physiology and all the things. And aerodynamics is of central importance for wind engineering applications. For the competition, you need to know a few facts. So if you look at this schematic, you see a building, and then that's a wind profile. Can you tell me, like, why do you see that the wind speed increases with the height, and near the ground it's kind of very low or almost negligible? Any idea why that happens? Yeah?
There's a little more friction near the ground, and some of the tree also stop.
Okay. Any other explanation? Okay. I think he's absolutely correct. So as you see near the ground, we have so many things blocking the wind, so it produces friction. So as we move higher and higher, the wind speed increases based on a power law. So just remember that when you envision the wall of wind running, the wind speed near the ground will be lower, and it will gradually go up in that profile. So which is important for you to understand. Also, as you can see in that picture, the wind speed is not uniform. It's not like 10 miles per hour, a constant, but you can see the mean of the wind speed plotted here is about, let's say, 5, and the wind is turbulent, so the wind varies, the speed changes with time. So again, at the wall of wind, you're going to get these kind of turbulence effects, so the wind is not uniform, the speed is going to change. Sometimes it will go higher, it will go lower, and that's how it's going to behave. Can someone tell me what the top picture is? What does it look like? Exactly. And these two are more like rounded shape or irregular shaped bodies. What do you see is the difference between the picture A and B and C? Let me just tell you that these lines we see, these are called streamlines. It shows how the wind goes, how the wind varies after it hits the body, and this is the downwind side of the body. So looking at the streamlines of A, B, and C, what difference can you see between those different bodies here, A, B, and C? Yes.
The aerodynamic object is able to utilize Bernoulli's effect so that while it's small, the air goes around and meets together at the same time, while the other are not, like, they're irregularly shaped, so the wind is kind of being violently pushed around that object.
Very good. Anyone else? Yes.
Wind turbulence.
Wind turbulence, okay.
Because picture A aerodynamically, passes through the wind compared to B and C, which actually obstruct the wind and make it harder. More friction is on the object, so move that out. The first one actually flows through the wind compared to the other one, which actually object it.
Okay. Very good. Anyone else? Okay, I think both are very good explanations. So the top body is an airplane wing. It's called an airfoil shaped body, and it's aerodynamic, or it's streamlined. So you can see that the streamlines remain mostly attached to the body. Here, what I see, because I have a rounded body and this is another irregular body, I form a wake because the wind separates. It cannot negotiate that abrupt ending of the body. So all I have here is turbulent wakes and a lot of turbulence in the flow. So buildings are like that, or any civil engineering objects are like that, because they are rounded or sharp edge bodies, unlike planes. And you're going to see those effects. So these kind of bodies we call bluff bodies, and the top one we call streamline and aerodynamic bodies. So this is an example of such a bluff body which has sharp edges. What you see here is the wind coming and it hits that corner and the wind separates, just like, because it's not a streamlined body like a plane wing. So what you create here is a lot of turbulence and vortex that form, and you can have very high uplift or suction pressures. In hurricanes, you have seen that tiles flying off the roof and shingles flying. That's because of those kind of uplift pressure on the roof. And as the wind hits, some of the wind comes down and forms a standing vortex at the lower portion of that building. So this portion is very important for this year's project that you're going to do, because that's what we are looking for, because that's a problem. Why that's a problem? Because if people are standing here, then they feel that wind and those big standing vortices, and it becomes a problem for pedestrians. All right? So I'm going to skip that. So that's a picture of how wind can be very uncomfortable to people on the ground level, and you see that they are almost holding something to make sure that they are not blown off. So wind can be very dangerous to pedestrians. Okay. Now, how do we stop these kind of situation? We can design wind brakes. As you can see, what is a wind brake? What does this look like? This picture. Huh? A what?
A wall.
A wall. A wall? Holes. Okay, a wall with holes. So this is almost like a screen, right? So you have holes. So what happens is some of the wind can get through it, and it forms again some vortex here, and some of the wind blows over, and it's going to go over like that. So if someone is standing here, this barrier will have an effect on reduction of the wind speed that that person is going to see. So without the windscreen, if he sees, let's say, 20 miles per hour, then probably with the windscreen he's going to see 10 miles per hour or so. So these kind of wind brakes can be porous or solid, and they can give you some sheltered effect behind the wind brakes. And how much sheltering you're going to get depend on the porosity. How many of you think that if this is very porous versus this is solid, what will happen to that person and the wind that he's facing? What happens if it's completely solid?
Want to just form the vortex again?
Where?
On the outside?
Okay. Yes, definitely. What? But I'm more interested in the inside. What happens to the person?
Maybe if the wind is going over the top, it could create a suction pressure. Suction inside to maybe lift the person, or uncomfortable with the person. Or if it's very porous, if it's very porous, then it'd be too much wind towards him.
Okay.
And if it's you gotta find the middle spot.
Very good. I really like your answer. So when we design this wind brake, you have to think about like an engineer, like he did. So if it's very porous, it's almost having nothing, right? So it's not going to stop anything. You're going to have 20 miles per hour coming, and this guy is going to see almost 20 miles per hour. If it's very solid, then most of the wind will be blocked on this side, but then the wind is going to separate, and somewhere it's going to come back to the surface, right? And wherever it comes, if people are standing there, they can feel very uncomfortable. So don't ever think that just putting a solid is going to make things good, or putting it very porous is going to make things good. So there is a middle ground of what porosity is going to be the most effective or optimum for this person to feel the least effect of the wind. Is that kind of clear? Yes. Because that's the crux of your project. So wind brakes are often used to protect vegetation and other kind of things. So we can use either solid or porous screens. They're going to get this presentation, right?
Yes.
Okay. So you can read all of that, but I'm just giving you the main points. So here is a porous screen. And the porous screen has a capacity of stopping some of the wind. So we can define the solidity ratio of this screen by the solid area, which is the total area minus those holes divided by the total area. That's the solidity ratio. And the porosity ratio is if we just take the holes and divide it by the total area, that gives you the porosity ratio. So you have to design a certain porosity which is best for the wind to behave for people who are standing. So this is a situation where I have the wind and this is a standing vortex forming, and so I have to protect the people from the standing vortex underneath the building, and this has been done in many cases. We design the building so that these kind of things do not happen. So what do you see here? For example, here I have built like a canopy and some person is standing here. So that standing vortex coming is not reaching that person, but it's deflected from that canopy kind of thing. So it's protecting that person from getting high winds. Another thing is called channeling effect. So let's say I have two tall buildings. What happens then as the wind moves, the wind is squeezed between this area because we have like a contraction. The wind is coming and then it forms like a wind tunnel. So inside that space, you're going to have accelerated wind. And if someone is standing between two tall buildings, he can feel very strong winds. So that's another aspect that we need to remember. So what are the comfortable wind speeds for people? If we are walking, then a comfortable wind speed could be anywhere from 0 to 5.4 meter per second. If we are sitting, it's 0 to 2.6, and that's how you convert meter per second to miles per hour. So these are kind of the safety or comfort wind speeds for people. Now, if I give you a practical example, this is a casino at Las Vegas. So what's going to happen is this building is there. So all that wind that comes, okay, is going to hit the building and we are going to form all those standing vortex here. So if I have a swimming pool or a patio or like a party going on at the basement here, then we have to design this whole situation for the pedestrian wind, so it's not, so that area is not unusable, because if you don't design it properly, there could be so much of wind that whatever people are doing here will be extremely uncomfortable because of the wind that's getting reflected from the building. How do we do that? We do that through wind tunnel testing. So this is a model of the same building, this building, modeled at small scale using a wind tunnel. Why do I say small scale? It's a 1:100 or 1:200 scale. So you take the building, if it's 100 meter and if the scale is 1:100, the building comes to a 1 meter. So you put a model here, you put all your architecture just like the actual building, and then you put it inside a wind tunnel and you blow the wind, and then you study using probes what will be the velocity that people are going to see when they're standing at those locations. From that we can make an estimate of what will be the winds for the actual structure, and based on the table that we showed you, like what are the comfortable wind speeds for walking or standing, we have to make sure that those wind speeds are not exceeded. Is that clear? Okay. This is another hotel example. Again, this is an example of channeling. So if people are standing here, then they kind of face the accelerated wind going through the restricted area. So everything like this is modeled in the wind tunnel. This is another wind tunnel model. So you have to build a scale model and you have to test the wall of wind. And that's the wall of wind which Eric is going to show you after this. And the problem given to you is similar to that hotel, but it's a much simpler situation. What you're going to have is you're going to have a 6-story hotel. So what is the height of a 6-story hotel? Tell me, like, approximately. How much?
120.
120 what?
Feet.
Feet?
Sorry, we're in meters.
Meters?
40
What is 1 story? What is this room?
10 feet.
10 feet. 15, 10, 15, so 10 times 6, 60 feet. So we are looking at about like 60 feet, or maybe 65 or 70 feet of that building. Okay? And then what we have here, we have a 6 feet distance, which I believe is, so this is a model scale. Do you know what the model scale is?
How tall that one is?
No, what is the, like, is it 1:20, 1:100? Is it given anywhere?
I don't know if it is. It would be moving forward if you see it. We can add that if it's not. But we know.
Anyway,
25.
this model is going to be provided to you. It will be in the wall of wind, the blue building, and that's a, I don't remember what scale we are doing, but it's a
Does that say
basically.
there, a factor of 25?
Oh, okay, so it's a 1 to 25 scale. So this scale is 1 to 25. 1 to 25 means, 1 to 25 means if I have the building as, let's say, 75 feet, just for an example, that hotel, then the model will be 75 by 25, which is 3 feet. So this at the wall of wind will be 3 feet. Okay? So everything else will be scaled. So when I say this is 6 feet in the wall of wind, what is that in the actual situation? Can you tell me?
150.
How do you get that?
6 times 25.
Exactly. So everything here, if you want to know the full scale dimension, you multiply everything here by 25, right? So the 6 feet becomes 6 times 25, which is whatever that is. That 8 inch will becomes 8 times 25 in inches, and then you can convert back to feet. This 8 feet is 8 times 25, which is, what is 8 times 25? 200? 200. So actually you are given a 200 feet area by 8 inch times 25, whatever that is, about, let's say 20 feet. So you are giving like a 200 feet by 20 feet area, which is that pink area. It's scaled down to a 1:25, right? And these blocks that you have here represent, let's say, people. Okay? That means the situation here is we are at a Caribbean island in front of a hotel. This is the ocean, this side, and we are going to have a party. Let's say an FIU party after the Wall of Wind Challenge. All of you are there. Okay, 50 people or more. Okay, we are celebrating the first and second and third places of the Wall of Wind Challenge.
It's Miami Beach.
It's Miami Beach. Great, it's Miami Beach. So that's even better, we don't have to fly. So what happens is from the Atlantic Ocean, we have the wind coming in. And the wind is going to get deflected by this building, right? And it's going to form all those standing vortices and things here. Also, the wind is going to separate, because this is a bluff body, it's going to separate from the edges, right? So it's going to affect all the people that are here, right? So how do we protect? So how do we have a nice party without having people tipping off or blowing off or hitting each other because of the wind? What we can do, we can put windscreens here. Okay? So each of the team has to build a windscreen or a set of windscreens. Now the rule is that you cannot go outside that pink. Okay, so this is an 8 feet by 8 inches. Are we going to give them a board?
Yes.
Where they're going to put this?
Yes.
So you'll be provided with a 8 feet by 8 inches platform,
Yes.
on which you have to design the screens. Now you can have multiple screens. Let's say you want to have 4 screens. You put 4 screens. But remember, if we put 4 screens, if one has a porosity of something, as you add more, the effective blockage increases, right? It becomes almost solid. Then what happens? You have a chance of the wind, people closer to that screen, to those screens, may see less wind, but people standing farther from the screen might see higher winds. So here we are going to, how do we measure your performance of your design? we are going to see how many people or how many of those blocks fall down. So if the team that will have minimum number of people falling down is of course the best design, right?
Yes.
You have a question?
Yeah. Is there a height limit to the web screen?
Yes, I'm going to go to that because you could make these like 10 feet tall and nothing will happen. So we give you a height limitation. Now the height limitation also comes from the fact of the economy. You have to just understand that in practical life, if I have to build something, I have to make sure that it's the best design, it's cheap, but it's effective. So I cannot go and build something, if the hotel is 60 feet, I don't want to build like a 30 feet tall fence because it's going to cost us much. Again, I can have 2 screens or 3 screens, but that's going to increase the cost. So there is again a balance. There is another aspect of it. If I put many screens or if I put a solid, very large wall, why do we like beaches? Why do we like these kind of hotels? Because you can see the ocean.
Yeah.
Because you can see the ocean and that's a relaxation for people. So if you put like a very solid or 2-3 screens which is completely blocking the view, then it's an aesthetic problem for the hotel. You're not going to enjoy the party. It will look like you're inside a hallway or something, not in the Miami Beach. So all those factors you have to think about. That the wall of wind challenge is not just about mitigating the wind, but it's also about the architecture. Okay, so you have to figure in what's the best design that's going to protect most of the people from falling, what will be something which is cost effective, and how aesthetic it's going to look, so that people can also see the ocean and things like that. So all of that you have to think that this has to be really bought in by the architect, and that's what happens in practical life. You can go and say, I want to design this, and the architect of that hotel is going to come and say no way, and the owner is going to say no way because it's blocks, and so I will lose clients. So there are certain rules, definitely. So here are the rules here. Teams are tasked with developing windscreen that will provide the best shelter for the leisure area, which will be measured by how many of the blocks fall over as the wind speed is increased. Teams must develop and construct their chosen windscreen in compliance with the requirements and restrictions that follow. So what are the restrictions? These are the restrictions. Each team will place their windscreening device on a 3/4 inch, which is on a 3/4 inch plywood board. So that's the thickness of the plywood board that we are going to supply. And the board is 8 inches wide by 8 feet long, as shown in the diagram. Other components of the scale model property will be created by the FIU. So we are going to put all those dummy people and the hotel, all that we are going to do. Each team will bring their plywood board with wind screening device to FIU on May 20th for the live testing. And the windscreen can be no more than 6 inches high. But as I said, you can have multiple screens just as long as they remain within your 8 inch by 8 feet area. Okay? The screens can be straight or curved. So if you think that I'm just going to put a single screen and that's my board and I'm going to make like this, you're free to do it as long as you don't exceed. You can add another screen if you want in some other fashion. You can add another screen. But again, as you put more screens, you have to make sure that you're not shifting the problem from here to somewhere here. Okay? So there must be a 3-inch wide passageway within the 1 foot of the center of the screen that allows hotel patrons to have access to the beach. So this is another point. You have to have a passageway so that people can go, and then all of that is scaled for with that 1 to 25. So there will be a hole, right, in the screen, so people can pass. So these are the rules that you have to follow. We are going to watch the test, and we are going to watch how many blocks are blown over. And then each team will be supplied with a $50 cash. Teams are permitted to spend more than the provided $50, but any additional cost incurred shall be at the expense of the team. Any type of non-hazardous material shall be allowed and considered acceptable for designing the screen. So you might choose foam, you might choose wire, you might choose plastic, porous, or anything you want. Given that the solution complies with the construction guidelines that we showed you, some common examples of acceptable materials, but not limited to wood, foam, bulk screen, plastic, metal, white glue, super glue, and epoxy. During the completion, each team's screen model will be placed in the wall of wind and tested by gradually increasing wind speed. So this is how it will happen, and it really gets interesting because you'll be sitting there, and let's say one team goes and tests. So we are going to start the wind speed from, let's say, 15 miles per hour at the wall of wind, and we are going to increase it to 20, 30, and then you're going to see things falling off, right? And then only once wind screen model will be accepted for each team for wind testing. All models will be tested for one wind direction, 90 degrees, so the wind is blowing straight to your fence and the hotel. And we are going to go to a certain wind speed, and we are going to see how many things are falling. That wind speed, constant wind speed, will be same for all the teams. So let's say we go up to 100 miles per hour, then we are going to see the team that's going to win, not win, that's going to get the highest points in the wall of wind testing will be the team with the least number of those blocks falling off at that highest wind speed. All right. No one is allowed in the wow test area during testing. All of you will be sitting inside the control room because it's that's the regulation. And I guess there will be judges who are going to see, and you're going to make a presentation to them. Maybe that part, if you want to explain to them, then Eric, you can come and explain to them. Any questions before I give it to Eric? Yeah.
For materials, would honeycomb be allowed?
Yes.
All right.
And honeycomb can be made out of any material. It could be, foam. It could be cardboard. Yeah, definitely.
All right.
Any other?
Deadlines?
I'll explain the deadline. Okay.
All right, thank you.
Let's give him a big hand. Take the question. Unique experience to be able to test your project with the real wall of wind, and then also a presentation by Dr. Chowdhury. He is one of the experts in the world in wind engineering and using the wall of wind. So this is very exciting for all of you. I think the one comment about finding the right porosity and so on, this kind of another phrase, the sweet spot. Find that sweet spot. I think your one comment was kind of real important comment on this competition, finding that sweet spot of porosity or non-porosity for this. Also, I'll mention the oral presentation. That'll be a live part of the day as well. All the details of that will be given to you, but it's roughly a 7-minute presentation. Of the 4 students that are there that day, all 4 can participate in the oral presentation, or just one. Either way, the other 3 can just be helpers. But for that oral presentation, you're going to show a PowerPoint, you can show video, you can have hands-on things in front of you, you can use all multimedia that you want for that 7 minutes. But it only can be 7 minutes, which means you should practice through your PowerPoint, practice your presentation. Dress code is going to be professional dress code. Part of the oral presentation is also going to be, I believe, pretending that you are an architect, an engineer, and this is going to be a brand new hotel in Miami Beach, and they need to have this wind block. And you're going to be an architect or engineer applying or bidding for that project. And so you're making a presentation to sell your project and tell them how valuable it is and how it's going to look. So you have to think in terms of those kinds of presentation skills for the oral part, which will be on the day of the competition as well as the physical test. Again, I'll be providing the PowerPoint to all of you on the web page, and I'm going to email it to all the team teachers. And this presentation, as I said, recorded, will stay on the website. All questions are good questions. Big questions, little questions, as they come up, please feed them to me via email. We'll make sure they get answered as quickly as possible. As I said, all of you are going to receive the long, 8-foot long by 8 inches piece of plywood. That'll be delivered to your school, or you can pick them up here. So you'll be provided that, the $50 in cash to help buy some of the materials as well. And as I said, transportation will be provided for you, and that'll be arranged before May 20th. Any other questions at this point? Okay. Well, thank you for coming. We're very excited for the competition. We wish you all the best of luck. We know it's going to be a great experience for all of you. Thank you very much. You can end the recording now. Thank you.